Well, you see, there's something quietly curious about the way we look at our cosmic neighborhood. Let me ask you this. When you picture the solar system, do you imagine the planets huddled neatly together, almost shoulder to shoulder, drifting in a tidy clockwork dance? And, have you ever wondered why those images feel so right even though, deep down, you suspect they might be wrong? I suppose it's because our minds prefer comfort over scale. They draw the sun small enough to fit the page, the planets close enough to keep things tidy, the distances trimmed so your eyes don't have to wander too far. But out there, in the real expanse, everything stretches and stretches until the truth becomes almost unsettling. And that's the thing. The true scale of our solar system is not something we see. It's something we have to feel. A kind of widening in the chest, a slow inhale, as if the universe itself were whispering that space is not a diagram but an ocean. By the time we reach the edge of it, well, the humble little world we call home is barely more than a dot, a note scribbled in the margins of a vast book written in starlight. Perhaps tonight, as we talk in the soft stillness of a late hour in this year, 2025, we can gently unfold those distances together. Let the mind stretch. Let curiosity wander. Because once you glimpse how large it all really is, even the silence between planets begins to feel like a story waiting to be told. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. Well, you see, when we turn our attention toward the sun, toward that immense and glowing heart of our solar system, something rather humbling begins to stir in the mind. And, I suppose it always starts the same way, with the quiet realization that the star we greet each morning is not simply a bright disk in the sky, but a colossal sphere of fire and gravity, so large and so overwhelmingly dominant that every planet, every comet, every drifting shard of rock we have ever named is merely responding to its pull. Yet we rarely feel that truth emotionally. We live our entire lives under its light, but the scale of it, the meaning of its presence, sits just beyond the reach of ordinary intuition. Perhaps that is why, as we talk tonight, the sun becomes a kind of doorway into awe, an anchor that invites us to stretch our imagination just a little wider than usual. Imagine, for a moment, holding Earth in your hand. Not the real Earth, of course, but a little peppercorn, smooth and dark, resting on your palm. Now picture yourself placing a ball the size of a small room 2 meters across beside it. That enormous sphere would be the sun, and the tiny bead you hold, that is our world. You see, we say such comparisons often, as if they were trivial analogies. But when you slow down, well, something happens. You notice the absurdity of it. One object dwarfs the other so completely that they hardly belong in the same sentence. That is the true relationship between our planet and the star we orbit. And yet it is not only the size that matters, but the consequences of that size. The sun contains more than 99% of all the mass in the entire solar system. Everything else combined, all planets and moons and meteors and the countless icy relics sweeping through the dark, amount to little more than grains of dust drifting around the overwhelming weight of this star. And that weight, well, it reaches far beyond its visible edge. The sun is not merely glowing. It is trembling with nuclear fire. At its core, atoms are crushed under pressures so great that hydrogen itself, the simplest and most abundant element in the universe, begins to fuse into helium. In those moments of fusion, immense bursts of energy are born. Yet here's the part that always makes me pause. The light produced at the sun's center does not simply burst out into space. No, it struggles. It ricochets from particle to particle, wandering not for minutes or hours, but for tens of thousands of years, possibly more than 100,000, before it finally reaches the surface and escapes. So the sunlight falling gently on your window tomorrow morning began its journey long before human civilization learned to speak, long before the stories of our species were carved into the fabric of memory. The warmth on your skin is ancient, a traveler delayed by the density of a star. And when you think about it like that, you start to realize how strange time becomes near something so immense. We often imagine the sun as a blazing instant, a constant and immediate presence. But in truth, the energy we receive today was born in a long forgotten age. Time inside the sun is thick, almost syrupy. And perhaps that tells us something about ourselves. We move quickly, we measure our days in hours, our years in brief cycles, yet the thing that sustains us moves in rhythms so slow and so monumental that our entire lives pass like the flutter of a leaf beside them. Sometimes I wonder what it would feel like to stand near the sun if we could somehow protect ourselves from its impossible heat. Not on its surface, but close enough to see the roiling oceans of plasma, the magnetic arcs rising and falling like fiery bridges, the constant storming of energetic particles. The surface is not solid, not fixed, but alive with convection, boiling and folding and unfolding in great luminous cells. And these motions, these patterns, they tell us that the sun is not a quiet lantern, but a restless engine. It breathes in cycles, experiences mood swings of activity, and occasionally sends great flares sweeping across space, ribbons of charged particles traveling outward at incredible speeds. The more we look at this star, the more it seems like a paradox. It is steady enough to nurture life, yet chaotic enough to shape the history of planets. It is simple in composition, made mostly of hydrogen and helium, yet complicated in behavior due to its magnetic fields twisting like invisible vines beneath its surface. Even its rotation is strange. The equator spins faster than the poles, as if the sun itself cannot quite make up its mind about how to turn. We often imagine stars as perfectly symmetrical things, serene and unchanging. But the sun is deeply imperfect, deeply alive in ways that mirror our own contradictions. And perhaps that imperfection is what makes it so captivating. When you tilt your head back and feel its light, you are not simply experiencing warmth. You are touching the edge of a process that has been running for billions of years, a furnace held together by gravity and balanced precariously between collapse and explosion. If the sun were slightly smaller, fusion might never have ignited. If it were slightly larger, its lifespan would be far shorter, and life on Earth would not have had the time it needed to develop. So we live unknowingly in a delicate window defined by the mass of a star. Now you see, when we return to that little peppercorn Earth in your hand, floating far from the great sphere of light, it becomes easier to understand our place. We exist only because we orbit at a precise distance, far enough to avoid being scorched, close enough to avoid freezing. In the cosmic ocean, this region is sometimes called the Goldilocks zone, but I prefer to think of it as a fragile path carved through fire and cold. And when you picture the Earth moving along that path, held by the invisible tether of gravity, you begin to feel how dependent we are on the sun's constancy. It is tempting to think of the sun as eternal because it feels eternal to us. It rises every morning without fail. It powers the winds and rains. It grows the forests. It sets our biological clocks. It defines what we call daytime. Yet even this giant has a lifespan. One day, far in the future, long after every memory of humanity has dissolved into history, the sun will expand and reshape itself, shedding layers and transforming into something new. But for now, in this moment, in this quiet part of the universe in the year 2025, it is stable, generous, and remarkably suited to nurturing life. I suppose what strikes me most is the intimacy of it. This gargantuan star, this near incomprehensible engine, feels personal. Every breath you take, every tree that grows, every ocean wave that rises and collapses, owes itself to the sun. And yet the sun is not aware of us. It does not shine for our sake. It shines because that is what stars do. We are the ones who attach meaning to its radiance. We are the ones who look up and feel a sense of connection. And that connection, well, it tells us something about human nature. We crave belonging, even in the vastness of space. We seek familiarity in the unfamiliar. We reach for metaphors to make the incomprehensible feel close enough to hold. So the sun becomes a presence, a companion of sorts, a constant reminder that energy and life are woven together in ways we barely understand. Perhaps that is why the ancient civilizations worshipped it, not because they misunderstood the science, but because they felt the weight of dependence, the vulnerability of existing in a universe where darkness is the default and light is precious. But here is where the story becomes even more astonishing. For all its size, for all its might, the sun is still only a medium-sized star, an average player in a galaxy filled with hundreds of billions of others. And yet it dominates our entire cosmic neighborhood to such an extent that every planet is simply a reflection of its influence. To explore the solar system is to explore the sun's legacy, its reach, its shaping hand. And as we move outward from the sun, the emptiness grows, the light thins, the heat fades. But the story of scale does not end here. In fact, it is only just beginning. Because once we step away from the sun itself and look toward the orbits of the inner planets, we start to discover an entirely different kind of strangeness, one defined not by size, but by distance. And that shift opens a new question, perhaps even more unsettling than the first. How much space truly lies between the planets that orbit this star, and why do our minds struggle to grasp those intervals? Well, that is where our journey naturally leads next, into the quiet and surprisingly vast gulf that stretches between the sun and its closest companions. Let us drift there now, gently, and see what the darkness reveals. Well, you see, once we drift away from the sun's overwhelming presence, something subtle begins to happen. The light softens, the temperature falls, and suddenly the story of scale shifts from sheer size to sheer emptiness. And perhaps this is where our intuitions, shaped by tidy textbook diagrams and classroom posters, quietly betray us. Because those diagrams, they place the planets so close together that you could almost imagine reaching from one to touch another. Neat arcs, smooth colors, everything arranged as if the solar system were a decorative mobile hanging above a child's bed. But out here, beyond the fiery edge of the sun, the first fact that settles into the mind is this: the distances between planets are far, far greater than the planets themselves. And that realization, well, it opens the doorway into the true scale of space. Take Mercury, the first wanderer. In most illustrations, it sits almost hugging the sun, a modest little sphere painted just a finger's breadth away from its star. Yet in reality, Mercury orbits tens of millions of kilometers from the sun. The distance is several times larger than the sun's own diameter. Imagine that for a moment. If the sun were truly the size of a great glowing sphere 2 meters wide, Mercury would not be circling just beside it where your hand could reach. It would be placed many meters away, drifting alone in a stretch of space so empty you could walk several steps without encountering anything at all. And, this is where the mind begins to stretch, because Mercury, despite being the closest planet to the sun, is already separated by a gulf that feels disproportionate, almost unnecessary. But the universe is not designed for our convenience. Its architecture favors vastness. And then, you see, before we even reach Venus, the second planet, we encounter another surprising truth. The planets are not arranged like beads on a string. They do not line up, they do not huddle, and they certainly do not sit equidistant from one another. Instead, each world circles the sun in its own lonely ellipse, sometimes nearer, sometimes farther, never synchronized with its neighbors. The spaces between them are enormous, far larger than the worlds that inhabit those orbits. It is tempting to imagine a system crowded with motion, a bustling neighborhood. But the reality is more like standing in a desert that stretches beyond the horizon in every direction, with only the occasional stone marking the presence of something solid. Consider Venus. In many models, it seems close to the sun, almost brushing Mercury's shoulder as the two glide along their paths. But in truth, the distance between Venus and the sun is tens of millions of kilometers. Even when the planets appear near each other on paper, in reality they sail through emptiness so deep that merely describing it feels insufficient. And yet, for reasons that have everything to do with the way we learn as children, we tend to shrink these distances unconsciously. We draw snapshots of the solar system as though it were a small family portrait, everyone crowding in to fit the frame. But nature did not place them so conveniently. Nature, in its quiet indifference, opened wide corridors between the planets. And then there is Earth. Our home, orbiting at a remarkable distance of roughly 149 million kilometers from the Sun. Think of that number not as a statistic, but as a journey. Light itself, the fastest thing in the known universe, requires over 8 minutes to cross that gap. 8 minutes is what it might take to brew a cup of tea, to tie your shoes slowly on a sleepy morning, to watch the sun rise. And during that span, a beam of light travels from the sun's surface across the cosmic void to touch the Earth. When you look at sunlight in a reflection, well, you are looking at something that departed the sun 8 minutes earlier. In a sense, every moment is a message from the past, a whisper from a distance so great it reshapes your sense of proximity. And perhaps the most striking part of all this is that these enormous distances belong only to the inner realm of the solar system, the region where the sun's warmth still feels generous and personal. Mercury, Venus, Earth, Mars, the planets we consider the nearest neighbors, are separated by expanses that utterly dwarf their sizes. If you could shrink every planet down to the size of a grain of sand, the distances between those grains would still stretch meters apart. You could scatter them across a field and walk among them without ever mistaking one for another. Space, even here near the familiar warmth of the sun, is almost nothing but emptiness. So why do our minds fail to grasp this? Well, I suppose it is because we evolved to understand forests, rivers, hills, things we can cross in hours or days. Our brains are not naturally wired for millions of kilometers. When we see a model that compresses those distances for convenience, we accept it without protest. We do not notice that the compression has erased the true vastness between worlds. And yet, once you bring it back into focus, once you truly feel the emptiness between orbits, you begin to understand the solar system, not as a tidy arrangement, but as a lonely archipelago scattered across an immense ocean. And the loneliness grows as we move outward. Even Venus, though seemingly close to Earth in size and beauty, is separated from us by millions upon millions of kilometers. At its nearest, it is still an extraordinary distance away, a gap so large that even the fastest spacecraft humanity has built would need months to cross. The space between planets is not just wide, it is remote in a way that speaks to the isolation inherent in the cosmos. What fascinates me most, you see, is how deceptive motion can be. The planets move quickly around the sun, Earth racing along at nearly 30 kilometers per second. Yet the orbits are so large that these speeds feel almost slow when set against the immensity of distance. If you stood outside the solar system and watched it unfold, the planets would appear to drift, not hurry, tracing their long ellipses as if in a silent, contemplative dance. And perhaps that slowness is part of the beauty. Time itself seems to expand in the presence of such scales. Now imagine again that peppercorn Earth orbiting the great 2-meter sun. Where would Venus be? Where would Mercury be? They would not be floating within arm's reach. They would be positioned several steps away, and Earth would be another long stride beyond Venus. And between these tiny worlds, there would be nothing. Not dust that you could see, not gas thick enough to notice. Just the near-perfect vacuum of space, clear and open and still. All of this, well, it prepares the mind for a deeper revelation. The inner planets, though separated by distances that already feel enormous to us, are actually the most closely spaced worlds in the entire solar system. They occupy a region comparatively compact and warm, a region where sunlight still holds shape and strength. But beyond Mars, the emptiness widens again, drastically. And the transition from the inner worlds to the next great realm of the solar system marks a shift not only in distance, but in the way we understand our own smallness. Perhaps that is the quiet power of contemplating these inner orbits. By appreciating the true spacing of Mercury, Venus, Earth, and Mars, by feeling the enormity of the voids between them, we prepare ourselves to confront an even more staggering truth. The planets themselves are tiny compared to the distances that surround them. And as we move forward into the next chapter of our journey, a new question emerges, soft and unsettling. If Earth is so small here, so delicate, so easily lost in the vastness between just a handful of worlds, then what does that say about our place in the larger cosmic arena? Well, that is where the story naturally flows next, toward the humbling scale of our own planet when set against the vast, silent architecture of space. Well, you see, once we've wandered far enough from the sun to feel the vast spacing of the inner planets, something gently shifts in our perspective. The distances have already grown so wide that they make the planets seem like solitary travelers adrift in a quiet cosmic sea. And yet, as we drift back toward our own world, toward this small blue sphere that cradles everything we know, a deeper realization begins to flicker at the edge of thought. Perhaps the planets are not the strange part of the solar system at all. Perhaps the strange part is us. How small we are, how local our concerns feel, how intimately we experience a world that, in truth, is almost vanishingly tiny when measured against the scale of space. And, I suppose it always starts with something simple, like imagining the Earth not as a globe held up by maps or diagrams, but as a coin, a modest little disc you could slip into your pocket. If Earth is that coin, then the sun becomes the size of a large football, bright and hot and overwhelmingly massive. Suddenly, the world that feels enormous under your feet shrinks into something fragile, almost weightless. When you stand on a mountain and gaze at the horizon, you feel as though the earth is endless, stretching far beyond what your eyes can follow. But from space, Earth is barely more than a bead. And from the sun's perspective, it is even less than that. And that's the thing. We grow up thinking of Earth as solid, substantial, immovable. But in the context of the solar system, Earth is more like a speck of dust in a cathedral of unimaginable scale. Our satellites orbiting overhead, those icons of human engineering, trail around Earth like grains of sand around a pebble. If you were to shrink Earth to the size of a grain of pepper, the satellites that encircle it would be motes of dust, nearly invisible, drifting along delicate paths just centimeters above the surface. Entire networks of communication, weather prediction, navigation, global observation. All of it balanced on the thin, glass-like edge of something barely represented in miniature. You know, what always fascinates me is how thin everything becomes when we reduce Earth to scale. The atmosphere, for instance, the very thing that keeps us alive, becomes a fragile skin. If Earth were the size of that peppercorn or coin, the breathable atmosphere would be thinner than the lacquer layer on a painted surface. Almost nothing. And yet inside that nearly invisible shell lives the whole of human history, every song we've sung, every discovery we've made, every hope and fear folded into the brief story of our species. When you look at Earth from space, the atmosphere fades into a pale blue halo, a whisper. And perhaps that whisper is what reminds us not to take our existence for granted. Now, if we turn our attention beneath the atmosphere, to the world itself, another humbling truth appears. The crust we live on, the portion of Earth where mountains rise, rivers carve their paths, and cities extend across continents, is astonishingly thin. If Earth were an apple, the crust would be the skin. Everything we build, every landscape we celebrate, every place we call home exists on a layer no thicker than a sheet of paper wrapped around a sphere. Beneath that layer lies a churning mantle, molten and ancient, restless and powerful. And yet we live our lives as though the ground beneath us is permanent and still. And perhaps that's why space feels almost unsettling when we confront it honestly. The things we consider large become small. The things we consider stable reveal their fragility. Even Earth's diameter, a number that sounds impressive in kilometers, becomes insignificant when compared with the path Earth traces around the Sun. If you picture Earth's orbit as a circle drawn on an immense canvas, Earth itself would be no more than a dot placed along that curve. You could stare at the orbit for hours before remembering there is a planet tucked somewhere along its length. And yet the most astonishing comparison emerges when we consider the space between Earth and its moon. From the ground, the moon looks close, like a companion gently floating overhead. But in truth, the moon is nearly 400,000 kilometers away, a distance so large that you could fit all the planets of the solar system between Earth and the moon, and still have room to spare. There is something wonderfully absurd about that. The moon, which feels almost like an ornament hung above our sky, is separated from us by a gulf vast enough to hold worlds. And, when you picture it like that, the relationship between Earth and the universe shifts again. We stop being at the center of anything. We become a participant in a much larger story. A story where even our closest neighbor is farther away than intuition allows us to believe. And that distance, well, it forces us to acknowledge just how isolated each planet truly is. But perhaps the most humbling realization arrives when we consider how little of Earth is actually usable or inhabited by humanity. If you peel away the oceans, the frozen poles, the mountain ranges, and the deserts, you find that the portion of Earth where most human life unfolds is shockingly small. Civilization clings to coastlines, river valleys, and fertile plains like moss to the surface of a stone. A thin band of existence wrapped around a world whose scale we rarely comprehend and whose emptiness we rarely notice. And even within that band, life endures not because of abundance, but because of balance, a balance maintained within a narrow range of temperature, pressure, and chemical composition. And there is another idea, you see, that often slips past unnoticed. We imagine Earth as the central stage of life because it is the only one we know. But the universe is under no obligation to match our intuition. Earth is not large, nor central, nor particularly special from a cosmic perspective. It is small, astonishingly so. It is fragile. It is temporary. And its place in the solar system is one of quiet insignificance. And yet, paradoxically, because it is our home, it feels immeasurably precious. I suppose that is where the emotional layer of this story emerges. The science is clear enough. Earth is tiny. The distances that surround it are vast. The structures we live within, from the atmosphere to the crust, are delicate. But the meaning of these facts lies in what they evoke. A sense of humility, perhaps. A sense of gratitude. A sense that life itself is something rare and improbable. Something worth nurturing. When we hold Earth in our mind as that tiny coin or peppercorn orbiting a star that barely notices it, the fragility of our existence becomes something beautiful rather than frightening. And perhaps that beauty lies in contrast. Earth is small, yes, but it is also complex. It holds oceans deeper than imagination, forests that breathe for the planet, deserts shaped by winds older than civilization, mountains rising from tectonic motions that began long before life existed. The smallness of Earth does not diminish its richness. Instead, it magnifies it. It reminds us that meaning and scale are not the same thing. A world does not need to be large to be significant. It only needs to hold life, memory, intention, and hope. But even with all that richness, even with all that life, Earth remains dwarfed by the distances around it. The space between Earth and the Sun, between Earth and the Moon, between Earth and Mars, all of it is so large that our world appears almost lost within it. And yet that very isolation might be what makes Earth special. Like a single candle in a vast dark room, its light becomes all the more precious because the darkness around it is so immense. And you know, once we have absorbed these truths, once we have felt the smallness of Earth settle into our awareness, something curious begins to happen. We stop seeing our world as the center and start seeing it as a participant, not a grand central figure, but a tiny note in a cosmic symphony. And when we make that shift, we become ready to confront another truth that is even more challenging. For if Earth is small compared to the vastness of its orbit, and if the space between Earth and the Moon can swallow entire planets, then what can we say about the distances that lie beyond? What happens when we extend our gaze from this small blue world to its nearest planetary neighbor? How does the story change when we turn from Earth's scale to the space that separates it from the next world along the Sun's great spiral? Well, that is where our journey naturally carries us next, into the quiet, hauntingly wide gulf that opens between Earth and the Moon's farthest frontier, and then even farther still, toward the world we call Mars. Well, you see, as we drift outward from Earth and into the space that stretches toward the Moon, the scale of everything shifts once again, and perhaps even more dramatically than before. We've just spent time contemplating how small Earth truly is compared to the cosmic distances surrounding it, how it resembles a coin wandering around a vast football of fire. But now, when we turn our gaze toward the Moon, our closest companion, a world whose face feels familiar enough to recognize at a glance, something quietly astonishing emerges. For all the comfort we take in the Moon's gentle glow, all the stories we have woven around it, the Moon is far, far farther away than our senses imagine. And I suppose that's the curious thing. When you look up at night, the Moon seems almost perched on the sky like a lantern hung from an invisible branch, close enough that you might fancy you could reach it if only you climbed high enough. But in truth, it lies at a distance of nearly 400,000 kilometers from Earth. 400,000. The number is so large that the mind slides off it at first. It feels too big, too abstract. But perhaps the best way to feel it is to imagine Earth reduced to a sphere 1 meter across, a globe you could rest your hands upon. In that scaled world, the Moon would not be hovering close by. It would sit dozens of meters away, across an open expanse of nothing at all, like a smaller stone placed on the far side of a quiet field. And, that emptiness between them is not filled with anything comforting or familiar. It is nearly perfect vacuum, a gulf so still and so barren that even dust is unusual. The space between Earth and the Moon is one of the emptiest regions humanity has ever traversed, and yet it was across that gulf that a few brave astronauts once traveled, taking more than 3 days to cross the void. 3 days. Think about that. They were not flying toward another continent, nor toward an island or a distant shore. They were leaving the cradle of the world entirely, rowing themselves through darkness on a thin metal craft, guided by equations and hope. When you slow down and think about that journey, well, something in you softens, because that distance, which looks trivial on a classroom diagram, is anything but trivial. A spacecraft racing through space at thousands of kilometers per hour still needs days to cross it. The Moon is not just up there, it is out there, a world unto itself, orbiting at a distance so vast you could place every planet of the solar system between Earth and the Moon's orbit and still have space left over. And still, the illusion persists. Part of the reason the Moon feels close is because our eyes are tricked by its familiarity, its size, its clarity. We see craters with the naked eye, Maria spreading like ink blots across its surface, its curves so crisp against the night sky that we forget how enormous the gap between us truly is. The Moon appears large, and large objects feel near. But the truth is that the Moon only looks big because it is enormous in its own right. It stretches more than 3,000 kilometers across. Even so, it is so distant that you could line 30 Earths side by side between the two worlds without their edges touching. And you know, that realization has a way of making the night sky feel wider, deeper, almost eerily silent. Perhaps the most surprising part, though, is how empty that space is. We like to imagine space as a place filled with stars and dust, with drifting rocks and clouds of shimmering light. But the region between Earth and the Moon is profoundly barren. If you stood at one point in that void, there would be no sense of direction, no surface beneath your feet, no hint of motion. Only the distant shimmer of the Earth, glowing blue and white, and the quiet gray curve of the Moon, waiting farther ahead. The rest would be silence, a pure, absolute silence. And that silence, that starkness, reveals how misleading diagrams can be. In most illustrations, the moon sits almost glued to Earth's side, orbiting as though tethered by a short rope. But the real orbit is so wide, so spacious, that Earth and the moon are more like two solitary travelers, holding hands across a gulf. And when we draw them close for convenience, we lose the truth that makes the system so beautiful. The moon is a companion, yes, but a distant companion, circling with a patience too slow for us to perceive in a single night. And then comes something even stranger. We often talk about the moon's orbit as if it were smooth and simple, a clean ring drawn around Earth. But in reality, it is a dance through a landscape of gravity. Earth pulls on the moon, the sun pulls on both of them, and the moon moves not in a perfect circle but in a shifting ellipse. Its distance constantly changes. Sometimes it is 10,000 kilometers closer, sometimes it is 10,000 farther. It breathes in a way, moving in and out like an ocean wave. And perhaps that is why ancient cultures saw the moon as something alive, always present, always watching, yet always moving, always drifting between nearness and distance. We knew even then that it was no simple ornament. It was a world, one that shaped our tides, tugged on our seas, and steadied Earth's rotation. Without the moon, our nights would be darker, our seasons less stable, our planet more chaotic. And yet, even with its profound influence, the moon is not near. It is connected, yes, but proximity is not the same as relationship. Now imagine again, Earth reduced to a sphere a meter wide. Walk several steps away, keep walking. 10 meters, 20, 30. When you finally place the moon down, it is barely visible beside your feet. That is how far it truly lives from us. And in that space between them, nothing interrupts the emptiness. It is a corridor of darkness that astronauts once crossed with nothing but thin walls between themselves and the infinite. Perhaps that is why the first views of Earth from the moon were so moving. Looking back across that enormous distance, Earth appeared small and fragile, a glowing marble suspended in darkness. And from that vantage point, humanity suddenly understood something profound. Our world, bustling with life and noise and color, is a tiny oasis floating far from anything else. We forget this when we stand on the surface surrounded by forests and oceans. But from the moon, the truth is inescapable. Earth is alone. Beautiful, but alone. And you know, this sense of isolation is not meant to frighten. If anything, it heightens our appreciation. When we see Earth against the backdrop of space, its blues and whites and greens feel almost impossibly vivid. It becomes clear why life holds so tightly to that fragile layer of atmosphere. There is nowhere else nearby. The moon is too barren, too cold, too airless, and the next nearest world in the sun's care, Mars, lies tens of millions of kilometers farther still. And that, well, that is where our story gently leads us next. Because if the moon is already so distant that astronauts needed 3 days to reach it, if the space between Earth and the moon is so empty that even light takes a moment to cross it, then what can be said about the distances beyond? The moon, despite its great separation, is our closest neighbor. The closest world we can see without instruments, the closest destination we have ever reached. But beyond that pale companion lies a far greater emptiness still, stretching outward toward Mars. A world that feels close in imagination, yet is separated from Earth by gulfs that dwarf even the journey to the moon. And perhaps as we step beyond lunar distances and start to contemplate the long, cold corridors that lead toward the red planet, we will discover that everything we thought we understood about distance was only the beginning. So let us drift now from the moon's orbit outward into that wider desert of space where the path to Mars begins to unfold. Well, you see, once we drift beyond the gentle orbit of the moon and begin to contemplate the next world along the sun's great spiral, something rather profound happens to our sense of scale, The moon, for all its distance and silence, still feels like a neighbor, a companion that shares Earth's nights and tides. But Mars lives in a realm entirely different. It is not merely farther away. It is separated from us by a gulf so wide, so shifting, so untamed, that the journey to the moon suddenly feels like stepping across a small creek compared to the deep ocean that lies ahead. And perhaps that realization is where our imagination begins to stretch once again, bending toward the truth that the solar system is built not from planets, but from emptiness, with only occasional islands of rock or gas interrupting its vastness. And I suppose it helps to begin with something simple. Mars is often painted as Earth's neighbor, the next-door world, the dusty cousin with polar caps and seasons. We picture it as close. But close, in cosmic terms, is a slippery notion. The truth is that Mars is separated from Earth by tens of millions, sometimes hundreds of millions, of kilometers. That number alone is so large that the mind instinctively shrinks from it, tries to tuck it into something familiar. But perhaps it becomes clearer when we compare it to the moon. The moon lies less than 400,000 kilometers away. Mars at its nearest might be 50 or 60 million kilometers distant. At its farthest, well, it can drift more than 400 million kilometers away. The difference is staggering. The moon is like a stone at the far edge of a quiet pond. Mars is a city across an ocean. Even light itself takes minutes to reach Mars. A beam traveling at the fastest speed in the universe must labor for nearly 4 minutes at the closest approach, and more than 20 minutes when the planets are on opposite sides of the sun. That delay alone is enough to remind us that Mars is not a friendly next-door neighbor. It is a distant town, a remote outpost whose signals arrive long after they are sent. And that's the thing about Mars. Distance is not fixed. It breathes in and out. It stretches and contracts as the planets follow their elliptical orbits. Sometimes Earth and Mars draw closer, like two travelers whose paths briefly converge, and then, slowly, inevitably, they drift apart again, separated by unimaginable expanses. You know, spacecraft traveling to Mars must ride these tides of orbital motion. There is no straight line from Earth to Mars, no simple path across the void. You cannot point a rocket at Mars and fly directly there, because by the time you arrived, Mars would have moved. Instead, engineers must send spacecraft along curved trajectories, using the sun's gravity to arc toward Mars's future location. It is less a journey to a destination and more like tossing a message in a bottle into a swirling tide, trusting that the currents will carry it where it needs to go. And even with our best engineering, even at speeds that dwarf anything we experience in daily life, the journey takes half a year or more. 6 months in the vacuum of space, with nothing but the dull glow of instruments, the distant whispers of radio signals, and the slow drift of stars beyond the windows. And that long duration tells us something important. Mars is not a neighbor in any meaningful human sense. It is a remote settlement at the far edge of a vast wilderness. And perhaps that's why the early missions to Mars felt so monumental, even though they were unmanned. When the first probes arrived, they were like messages finally reaching a distant shore. And the time it took them to travel told a story about distance more eloquently than numbers ever could. They drifted for months, crossing a gulf so empty that nothing interrupted their path. No asteroids brushing past, no clouds of cosmic dust, just silence, cold and pure. It's strangely poetic to think of Earth and Mars as two travelers on separate circular roads, sometimes approaching one another, sometimes retreating, but never quite meeting. We refer to Mars as a near neighbor, but the nearest the two worlds ever come is still farther than any human has traveled. Imagine standing on Earth and seeing a world so distant that it would take a spacecraft half a year to reach it, and yet we call it close. That alone tells us something about the scale of the solar system. And then comes a deeper truth. Even when Mars and Earth are at their closest approach, that distance is exceptional. More often, they sit far apart, separated by hundreds of millions of kilometers. Entire seasons pass on Earth without Mars drawing nearer. Children are born and grow older before a new launch window opens. The pacing of interplanetary travel is glacial compared to human life. And perhaps that slowness feels comforting in a way, because Mars, with its deserts and canyons and traces of ancient rivers, feels like a world meant to be approached with patience. You see, when we imagine Mars in popular culture, it often appears just beyond reach, a place where astronauts step casually onto red plains, a destination for weekend science fiction. But in the real universe, Mars is staggeringly far. It is not an island off the coast of Earth. It is a distant town in another country entirely, a place separated by distances that swallow our conventional understanding. And maybe that's why the idea of human missions to Mars carries such gravity. The journey is not simply hard because of engineering. It is hard because of the distance. Once you leave Earth, there is no turning back. If something breaks, if something fails, Earth becomes a faint star behind you, unreachable for months. The Moon, by comparison, is practically next door. A spacecraft could return from lunar orbit in days. But Mars stands alone, unapproachable in any emergency, a distant world that demands commitment. And, there's something else about Mars that deepens this sense of isolation. When we talk about the distances between Earth and Mars, we often use the smallest possible number, the closest approach. But that number is rare. More often, Mars is extremely far. So far, in fact, that every world in the inner solar system could fit between the two planets with room left to spare. The space between Earth and Mars is not a narrow gap. It is an ocean. And that ocean moves, changes, expands, contracts, but never disappears. Imagine again that scaled model we used earlier. If Earth were the size of a 1-meter sphere and the Moon rested dozens of meters away, Mars would sit hundreds of meters beyond that, so far that you would need to leave the field entirely and begin walking down a long, quiet road. And along that road, nothing would accompany you. No sound, no landscape, only emptiness. And somehow that emptiness becomes part of the beauty of the solar system, because it reminds us that the worlds are not crowded together, but scattered like islands, each with its own history, each shaped by forces unique to its place. And perhaps that's why Mars has always captivated our imagination. It is far enough to feel mysterious, close enough to feel reachable. It lives at the fragile boundary where longing meets reality. And as we study it, as we dream of sending humans to walk its dusty valleys, we must never forget the scale that separates it from us. The distance is not measured only in kilometers. It is measured in patience, courage, and humility. But the most humbling revelation of all may be this: even Mars, with all its distance and challenge, is still part of the inner region of the solar system. It is still relatively close to the sun. It still feels the warmth of sunlight, though faintly. It still resides within the realm of rocky worlds. It is, in cosmic terms, only a step away. And that realization opens the door to something even larger, because beyond Mars lies a world so massive that it dwarfs every planet we have encountered so far. A world whose gravity shapes not only its own moons, but the architecture of the solar system itself. A world so far away that the sun, from its sky, shrinks to a pale spark. So as we leave Mars behind, drifting outward into colder regions of the sun's dominion, perhaps the question now becomes this: if Mars feels distant, remote, and nearly unreachable, then what does it mean to approach a giant like Jupiter? What happens to our sense of scale when the next world we meet is large enough to contain thousands of Earths? Well, that is where our journey carries us next, into the shadow of the first true giant of the solar system, where distance and size converge into something almost mythic in scale. Well, you see, as we leave Mars behind and drift farther outward into the cold architecture of the solar system, something almost mythic begins to rise on the horizon. It appears first not as a world, not as a sphere or a surface, but as a presence, a gravitational shadow that seems to bend space long before the planet itself becomes visible. And, when Jupiter finally emerges from that distance, glowing faintly beneath the thinning light of the sun, The scale of everything we've discussed so far suddenly feels inadequate. Mars may have tested our imagination, but Jupiter overwhelms it. It is the first of the giants, the first world that insists we let go of any remaining human sense of size, mass, or distance. And I suppose the best way to feel Jupiter is to begin with the simplest truth. Jupiter is enormous. Not large the way Earth is large, not impressive the way Mars is impressive, but colossal, cathedral-like, a world so huge that it contains more mass than all the other planets in the solar system combined. You could pour Earth into Jupiter 1,000 times and still have room to spare. And if Jupiter were hollow, Earth would drift within it like a bead inside a vast glass globe. That image alone reshapes the mind's relationship to scale. And yet Jupiter is not hollow. It is dense, swirling, layered, a world without a solid surface, composed mostly of hydrogen and helium under pressures so great they twist matter into exotic forms. Deep inside Jupiter, hydrogen becomes something strange, a metallic fluid capable of conducting electricity. It is a world that refuses to behave like a planet. It behaves more like a star that never quite succeeded in igniting. If it were only slightly more massive, Jupiter might have sparked into nuclear fusion, becoming a faint second sun. The solar system would have been a binary system. Imagine that. Twin stars lighting the worlds. But Jupiter remained just below that threshold, a failed star, glowing only with the heat of its own slow contraction. And yet, even without fusion, Jupiter's influence extends astonishingly far. Its gravity is so powerful that it sculpts the solar system around it. Asteroids drift in patterns shaped by its pull. Comets change course as they pass. Even the orbit of Saturn, farther still, is subtly shaped by Jupiter's presence. In many ways, the solar system has two architects: the Sun, which provides the light and the warmth, and Jupiter, which provides the gravitational structure, the great invisible scaffolding that holds so many orbits in place. You know, when spacecraft approach Jupiter, the first thing they notice is not the planet itself, but the sheer reach of its magnetosphere. Jupiter's magnetic field is the largest structure of any planet in the solar system, so large that if it were visible, it would appear bigger than the full moon in Earth's night sky, despite Jupiter lying hundreds of millions of kilometers away. This magnetic bubble stretches far outward, capturing charged particles and sweeping them into vast radiation belts. If Earth were placed inside those belts, life as we know it would be scoured away in moments. Jupiter is beautiful, yes, but it is also dangerous. It is immense not only in size but in energy. And then there are the storms. The Great Red Spot alone is a hurricane larger than Earth, a storm so vast that our entire planet could vanish inside it without touching the edges. And that storm has been raging for centuries, possibly longer. Imagine winds so strong, so relentless, that they have circled a world for ages without resting. Jupiter's atmosphere is a canvas of belts and zones, of storms rising and fading and merging, a fluid planet where color and motion never stop. It is a world sculpted by turbulence. But perhaps the most astonishing part of Jupiter is not the planet itself, but the family of worlds that orbit it. Jupiter's moons form a miniature solar system of their own. Io erupts with volcanoes more powerful than anything on Earth, fountains of molten sulfur rising hundreds of kilometers into space. Europa holds an ocean beneath its icy crust, an ocean vast enough to contain more water than all of Earth's seas combined. Ganymede is larger than Mercury, a world with its own magnetic field. Callisto, ancient and scarred, carries the memories of billions of years of impacts. Standing among these moons would feel less like visiting satellites and more like visiting planets in their own right. Jupiter, in a very real sense, is a solar system inside the solar system, and as we drift outward, leaving Mars far behind, the distance to Jupiter grows not merely in kilometers but in character. The sun dims. Its warmth softens. What was once bright and overwhelming becomes a pale disk in the sky. From Jupiter's orbit, the sun is no longer the blazing giant we know from Earth. It becomes a sharp, small circle of light, bright but compact, a reminder that even stars shrink with distance. And I suppose that change in the sun's appearance tells us something subtly profound. We are leaving the inner warmth of the solar system, stepping into colder, darker realms. The distance from Earth to Mars already felt immense, a half-year voyage across a void. But the journey from Earth to Jupiter is even longer, spanning hundreds of millions of kilometers. Spacecraft take years to reach it, slingshotting around planets to gather speed, drifting through emptiness that stretches far longer than human intuition can comfortably grasp. And when they finally arrive, the sun behind them appears so small that the spacecraft must rely on nuclear power rather than solar panels. Jupiter exists in a realm where sunlight is too faint to sustain even machines. And perhaps that faintness deepens the emotional weight of Jupiter. When you stand close to the moon, the sun fills the sky. When you imagine yourself on Mars, the sun still holds a familiar glow. But at Jupiter, the universe begins to reveal its true face: cold, silent, vast, indifferent. Jupiter feels like a gateway to the outer solar system, the first step into regions where darkness dominates. It marks the boundary between the worlds, shaped by warmth, and the worlds shaped by distance. And as we drift past Jupiter, something inside us shifts again. The giant planet, which seemed so dominant, so overwhelming, begins to shrink behind us as the void stretches onward. The light of the sun weakens further. Space grows quieter, and ahead, in the dark, another world begins to rise. A world surrounded by rings so delicate they resemble a whisper. A world almost too elegant to belong to the same family as Jupiter's raging storms. Because just beyond Jupiter lies Saturn, a planet whose rings glow like the spokes of a cosmic harp, wide enough to stretch farther than the Earth-Moon distance, yet thin as a sheet of paper in places. Saturn invites us not to marvel at size, but at beauty. Not at violence, but at grace. And so, well, as Jupiter fades into the backdrop and our journey continues, we prepare to enter a realm where scale meets elegance, where a world of gas carries rings of ice finer than frost, a world that in many ways feels like the solar system's quiet masterpiece. Let us drift there now, into the shimmering plain where Saturn waits. Well, you see, as Jupiter fades behind us and its great storms dissolve into the distance, the solar system begins to change character once again. The violence and raw power of the giant we've just passed leaves an imprint on the mind, a sense that we've crossed through the domain of a cosmic titan. But ahead, emerging softly out of the dimming sunlight, another world begins to reveal itself. And, it appears not as a sphere at first, not as a globe or a presence, but as a shimmer, a whisper, a thin, pale, gleaming arc that curves almost delicately across the darkness. And perhaps that is the magic of Saturn. It does not announce itself with thunder. It invites you in with beauty. Saturn is the poet of the outer solar system, the world that feels less like a planet and more like a dream suspended in the cold. Its rings appear so impossibly thin and luminous that you almost doubt they're real. They seem drawn rather than assembled from ice and rock. But the deeper you drift into Saturn's realm, the more the scale of those rings begins to unfold, and the illusion of delicacy melts into awe. You know, most images we see compress Saturn's rings so that they fit neatly into a frame. They look modest, decorative, almost fragile, but in truth, the rings are wide beyond imagining. They stretch out farther than the distance between Earth and the Moon. Imagine that for a moment. Take the space we spoke of earlier, the vast 400,000-kilometer gulf between our world and its companion, and then picture something even wider, even more expansive, orbiting peacefully around a world far from the warmth of the sun. And yet, for all this unimaginable width, the rings are incredibly thin, thinner than a single sheet of paper compared to their horizontal spread. A structure at once immense and delicate, a cosmic contradiction. And Saturn itself, well, Saturn is a contradiction too. For all its grandeur, for all the weight of its presence, Saturn is surprisingly light. If there were a bathtub big enough, an ocean of imagination rather than water, you could place Saturn within it, and the planet would float. It is made mostly of hydrogen and helium, less dense than water, a world of clouds and gases and soft layers drifting inward toward a small hidden core. And perhaps that gentleness, that lightness, is part of Saturn's enchantment. Jupiter demands respect. Saturn invites contemplation. But even in its gentleness, Saturn is no small world. Its diameter is more than 9 times that of Earth. You could arrange Earth side by side across Saturn's equator and still fall short of spanning it. And surrounding this colossal sphere is a retinue of moons so diverse, so strange, that they often feel like a menagerie of independent worlds rather than satellites. Among them is Titan, a moon so large it eclipses Mercury in size. Titan is a world with mountains, rivers, and lakes, not of water, but of liquid methane. A world with thick, golden haze and a landscape reshaped by rain. And the fact that this moon is bigger than Mercury, yet orbits Saturn like a loyal companion, tells us something about the scale of the giant planet. Titan could be a planet in its own right, but Saturn's gravity binds it effortlessly, as though it were just another small object in its family. And then there are moons like Enceladus, tiny yet astonishing, a frozen sphere that erupts with geysers from a hidden ocean beneath its icy shell. These geysers shoot water vapor and organic molecules into space, creating a plume that extends hundreds of kilometers. In the faint sunlight of Saturn's orbit, they shimmer like ghostly fountains. You see, Saturn does not merely host moons, it hosts wonders. But perhaps the most powerful truth of all emerges when we consider the distance to Saturn. We have already traveled far beyond Earth, past the Moon, past Mars, past the orbit of Jupiter. But the space between Jupiter and Saturn is enormous. It is not a short walk through the outer solar system. It is a long, cold desert where sunlight weakens, temperatures drop, and the silence deepens into something almost ancient. By the time a spacecraft reaches Saturn, the sun appears small and sharp, no longer a blazing disk but a bright star. Solar panels produce only a fraction of their earthly power. Light itself takes more than an hour to travel from the sun to this distant world. And that slow, steady dimming of sunlight tells us that Saturn lives in a region where warmth is a memory rather than a presence. And yet, for all this distance, Saturn is still visible from Earth with nothing more than a small telescope. That faint dot, shimmering with a hint of mystery, carries rings so large you could slip the Earth-Moon system between them. And somehow, that juxtaposition, the faintness of Saturn in our sky and the immensity of its true form, deepens the emotional weight of the solar system. It shows us again and again that what looks small from afar can hold worlds within it. You know, when astronomers first observed Saturn's rings, they didn't even know what they were seeing. The rings appeared as strange ears, strange bulges, strange shapes protruding from the planet's sides. Only later did we understand their nature and their scale. And even now, in the year 2025, our diagrams still mislead. They cannot capture the thinness, the brightness, the sheer breadth. Images condense them, simplifying something that refuses to be simple. But perhaps that is why Saturn has always felt like a planet, made not just for study but for wonder. And when we imagine ourselves drifting past those rings, through the faint icy particles that catch the sunlight like shards of glass, Saturn becomes a place where silence feels almost sacred. The sunlight is soft, the shadows long, and the emptiness vast. And yet, around Saturn, nothing feels harsh. Jupiter roars with storms, Saturn whispers in ice. But even as we marvel at its rings, its moons, its improbable lightness, we must remind ourselves, Saturn is far, very far. The trek from Earth to Mars feels like crossing a wide desert. The trek from Mars to Jupiter feels like crossing a deep ocean. But the trek from Jupiter to Saturn feels like entering another realm entirely, a realm where light dims and distances stretch and everything grows quieter. And beyond Saturn, the solar system widens even more dramatically, because Saturn, for all its grandeur, all its elegance, all its rings and moons and quiet beauty, is not the end of the outer planets. It is only the second of the giants. And as we drift still farther from the sun, into regions where sunlight becomes a pale echo of its former self, another world begins to emerge. A world tilted so dramatically that its seasons last decades. A world wrapped in an aquamarine haze. A world that glows faintly in the cold light of a distant sun. So perhaps the question becomes this: if Jupiter shows us size and Saturn shows us beauty, then what do the next worlds, Uranus and Neptune, show us? What truths lie in the dim blue regions of the solar system, where warmth fades and darkness deepens? Well, that is where our journey now carries us, into territories so distant that even a whisper from the sun takes hours to arrive, into the cold, quiet kingdoms of the ice giants, where scale and shadow merge into something wonderfully mysterious. Well, you see, as we drift beyond Saturn's shimmering rings and allow that pale golden world to settle gently behind us, the solar system begins to take on a new kind of quiet. Up until now, even in the deep cold beyond Mars, we have still been traveling through a realm shaped by warmth. Diminished warmth, yes, but sunlight that still feels recognizably like sunlight. But now, as we move toward the next great frontier, the light itself begins to behave differently. It thins, it cools, it loses the soft fullness we know so well. And, when you turn back toward the sun from here, it is no longer the blazing anchor of your sky. It has become a bright star, sharp-edged and small, a pale ember suspended in a dome of blackness. And that, perhaps, is when the nature of the outer worlds begins to reveal itself. Uranus and Neptune live not simply far from the sun, but far from our intuition. They are perched at distances so great that the mind must stretch like a rope pulled taut just to keep hold of the numbers. Hundreds of millions of kilometers have passed behind us already, and still these next planets lie billions of kilometers away. Billions. Even the word struggles under its own weight. And perhaps the cold is the next thing you feel. Not a cold you can touch or measure with your skin, but a conceptual cold. The knowledge that out here, at these distances, the warmth of the sun is barely a whisper. The temperatures plunge to hundreds of degrees below zero. The air, if you could call it that, is made of methane, hydrogen, and helium, drifting slowly in atmospheres so frigid that clouds form from substances that never behave as clouds on Earth. The blue-green glow of Uranus, or the deeper, colder azure of Neptune, comes not from a painter's hand, but from methane gas, absorbing the red part of sunlight, leaving only the icy blues to escape. And perhaps that is the subtle poetry of these planets. They glow with the faintest light, a kind of ghost light born from sunlight that has traveled for hours to reach them. And yes, light truly takes hours to arrive here. From the sun to Neptune, the journey for a photon can be more than 4 hours. Just imagine that. A beam of light, the fastest traveler in the universe, must run for hours through the vacuum before it touches the farthest of the giant planets. And when a signal leaves a spacecraft orbiting Neptune, it requires those same hours to return to Earth. Communication becomes a form of time travel. Every message arrives late. Every reply is delayed. Worlds this far out are not only physically distant, they are distant in time. You know, Uranus itself is a quiet enigma drifting through this frozen region. It rolls around the sun on its side, its axis tilted so dramatically that one pole points almost directly at the sun for decades at a time. Imagine a world where a single season can last 20 years, where the sun circles the horizon in slow, endless loops, where darkness can swallow half the planet for a quarter of a century. Life, had it ever risen here, would have learned patience beyond anything we know. And then there is Neptune, farther still, the windiest planet in the solar system. Winds whip around its atmosphere at more than 1,000 kilometers per hour, carving storms that dwarf those on Earth despite the faintness of the sunlight that drives them. Neptune is a world where motion remains fierce even at the edge of darkness, a reminder that distance from the sun does not quiet everything. Some worlds carry their own internal fires, but perhaps the most isolating truth of all is that we have never experienced these distances directly. No human eye has ever gazed at Uranus or Neptune from up close. No astronaut has floated above their clouds. The only visitors to these distant realms have been robotic spacecraft, tiny metal ambassadors drifting for decades through the dark before arriving at worlds so far removed from Earth that even radio waves must crawl slowly back. And because of this, our relationship to these worlds remains remote. They exist partly as scientific data, partly as dreams painted in pale blue. And yet, despite their remoteness, these planets quietly define what the outer solar system truly is. A place where sunlight weakens into starlight, where temperatures plunge so far that the very idea of warmth becomes abstract, where communication becomes delayed and distorted, where distance becomes something almost philosophical. Uranus and Neptune are threshold worlds. They do not simply lie far from the sun. They announce that we have entered a domain where everything familiar begins to fade. And, perhaps that is why the mind hesitates when imagining these regions. We evolved under the bright, immediate sun of Earth's sky. We understand seasons measured in months, not decades. We grasp distances measured in kilometers, not billions. But Uranus and Neptune break those instincts. They ask us to surrender our ordinary sense of place, to step into a cosmic scale that stretches beyond comfort. And the farther we drift, the more the sun dims behind us. Its light becomes fragile, its warmth becomes memory, and ahead lies a frontier even more astonishing, not a planet this time, but a region, a vast, icy expanse filled not with worlds but with relics, remnants, ancient frozen bodies that circle the sun from great distances, unseen, unlit, uncounted. The Kuiper Belt, a sprawling frozen ring that begins just beyond Neptune and stretches outward for billions of kilometers. A region so large that the inner planets, everything from Mercury to Mars, would fit inside it with room to spare. And within this region lie thousands, perhaps billions, of small icy worlds, cousins of Pluto, drifting silently through the sun's faint gravitational pull. So perhaps the next chapter of our journey beckons, not with the promise of grandeur, but with the whisper of billions of forgotten fragments scattered through a realm where sunlight barely reaches, a realm where the solar system no longer feels like a family of planets, but like a fading memory of a star's long past youth. Let us drift there now, into the Kuiper Belt, where the true outskirts of our cosmic home begin to unfold. Well, you see, as we drift past Neptune and its pale blue storms fade into the growing darkness, something subtle changes in the feeling of the solar system. Up until now, every world we've passed, no matter how distant, no matter how faint the sun had become, still felt like part of a coherent family. There was a rhythm to their orbits, a gentle spacing, a kind of architectural logic. But as we move outward into the Kuiper Belt, that sense of structure begins to dissolve. Perhaps the way the regular beat of waves dissolves into the open, irregular expanse of the deep ocean. And what replaces it is a kind of silence, a slow drifting quiet filled with ancient objects that no longer resemble planets, but rather memories frozen in ice. And I suppose that is the heart of the Kuiper Belt. It is not a place of planets, but a place of remnants, a place where the solar system keeps its old stories, its broken fragments, its frozen beginnings. If the inner planets are bustling cities, and the gas giants are towering capitals, then the Kuiper Belt is a wilderness, vast, untouched, and almost impossibly remote. And yet, for all its emptiness, it contains far more than we once believed. The first thing that becomes clear as you glide into this region is just how enormous it is. Back near the sun, the orbits of the inner planets felt spacious, Out near Jupiter, we began to sense the scale of the outer solar system. But here, the Kuiper Belt stretches for billions of kilometers. It is not a thin ring, not a narrow band, but a thick, sprawling expanse that dwarfs the region occupied by the 8 planets. If the entire planetary family were placed within a single small room, the Kuiper Belt would be the size of a cathedral surrounding it. The planets, for all their grandeur, fill only a tiny inner volume. The outer regions dominate the solar system's true geography. And drifting within this region are worlds as strange as they are numerous. Pluto, once considered the 9th planet, is merely one of them, a single grain amid a vast field of icy bodies. In truth, Pluto is neither lonely nor central. It is just one representative of a population numbering in the billions. Try to picture that. A billion icy worlds, each orbiting in the distant twilight, each following slow, elongated paths around a sun that barely warms their surfaces. A billion frozen relics from the early days of creation, still carrying within them chemical signatures of the solar system's youth. And, when you hold that image in your mind, Pluto itself becomes almost sentimental, a familiar name in a sea of countless unnamed neighbors. You know, one of the things that astonishes astronomers is how tiny Pluto truly is compared to the space it occupies. The Kuiper Belt is so vast that Pluto is like a speck of dust drifting in a frozen storm. If the Kuiper Belt were an ocean, Pluto would be a single drifting buoy. Its entire orbit covers a region filled with objects too small and too distant for us to see directly. We only infer their existence from slight gravitational tugs, faint blinks of reflected sunlight, or long-term orbital calculations that predict their presence. Many will remain unknown for centuries, but perhaps the most humbling truth of all is how dim the sun becomes out here. From the Kuiper Belt, the sun no longer fills the sky with light. It shines like a distant star, brighter than any other but undeniably small, undeniably far. Its heat weakens so much that temperatures plunge to levels unimaginable on Earth, hundreds of degrees below freezing. Even sunlight, that thing we take for granted as warm and immediate, becomes thin and blue here, incapable of melting even the most delicate sheets of surface frost. And yet, despite that cold, despite that distance, the objects of the Kuiper Belt remain loyal to the sun. Its gravity reaches even here, tethering billions of icy fragments to their slow, looping orbits. Some take centuries to circle the sun, others take millennia. The tempo of life out here is glacial. If you could stand on the surface of Pluto on the first day of your life, you would not live long enough to see a single Plutonian year completed. Not even close. And that's because a year on Pluto lasts more than 200 of our earthly years, a reminder that time stretches differently in the outskirts of the solar system. And perhaps that stretching of time tells us something deeper. The Kuiper Belt is not merely far from the sun, it is far from everything. Communication is delayed, light is delayed, movement is slow. This region is so vast that a probe launched from Earth takes nearly a decade to reach the threshold of it. And that journey represents only the beginning of the outer frontier. When New Horizons flew past Pluto, it spent years traveling through nothingness before meeting another object. Space out here is not merely wide, it is cavernous. But even in this cavernous quiet, there is history. These objects, icy, irregular, ancient, are the leftovers from planetary formation, the building blocks that never quite assembled into worlds. And so, the Kuiper Belt is a kind of cosmic museum, preserving the solar system's early materials in near-perfect condition. If we could scoop one of these icy bodies into our hands, melt it gently, analyze its composition, we would be tasting the chemistry of the solar system's birth. These worlds carry information older than Earth's continents, older than its oceans, older than any fossil or stone. And, there is something poetic about that. The Kuiper Belt is so far away, so faint, so frozen, that it rarely intrudes on our thoughts, and yet it holds the most ancient memories of our cosmic home. The solar system keeps its past in the cold, but even the Kuiper Belt, for all its size, is not the end. Beyond this region lies an even more mysterious frontier, the realm of comets with long, looping orbits, the region where the sun's gravity grows weak but not yet absent, a region so vast that we cannot see its objects directly, so distant that even the most powerful telescopes remain blind to them, the Oort cloud, a sphere of icy bodies extending outward nearly halfway to the nearest star. The Kuiper belt is enormous, yes, but it is only the inner foyer of this greater expanse. And perhaps that is the quiet transition we now face. As we leave behind the scattered icy worlds of the Kuiper belt, as we drift toward the deeper dark where sunlight becomes an afterthought, the question emerges softly. What lies at the true outer boundary of the solar system? What happens when the sun's influence finally fades into cosmic night? Well, that is where our journey naturally leads next, into the imagined, unlit, and almost mythic realm of the Oort cloud, where the solar system breathes its last whisper before yielding to the galaxy beyond. Well, you see, as we leave the Kuiper belt behind, its billions of icy fragments fading into the dark like embers drifting from a long cold fire, there is a moment, a kind of hush, when even the faint comfort of familiarity slips away. Up until now, every place we've traveled through has belonged to the solar system in a way our minds can still reach for. The planets, the dwarf worlds, the belts of ice and rock, they all orbit the sun in patterns we can trace, in shapes we can draw. But now, drifting outward into the silent black beyond Neptune's domain, something begins to change, not abruptly, but gradually, like the thinning of a breeze you didn't notice was there. And the dark here feels different, not just empty, but deep. And perhaps that's appropriate, because ahead lies the most mysterious structure in the entire solar system. Not a planet, not a ring, not a disk of debris, but a sphere, a vast, imagined, and almost mythic shell of icy bodies that stretches so far into the darkness that it defies all diagrams, all intuition, all notions of scale we've built so far. The Oort cloud. And I suppose the first thing to understand is that the Oort cloud is not something we see directly, not with telescopes, not with spacecraft, not even with the deepest instruments humanity has built. We infer it, we model it, we predict it, but we do not observe it. The objects here are too small, too dim, too distant for light to return to us. They hide in the cold, and yet their existence is written into the very behavior of long-period comets, those icy wanderers that appear suddenly in our skies after spending thousands, sometimes millions of years drifting in the sun's gravitational twilight. These comets come from somewhere far beyond the Kuiper belt, somewhere vast, somewhere ancient. Their orbits, when traced back through mathematics and time, point toward an invisible sphere wrapping the solar system like the faintest echo of its birth. And the scale of that sphere? Well, it pushes the limits of imagination. The Oort cloud may stretch nearly half a light year from the sun. Half a light year. If the distance from the sun to Neptune feels enormous, already, then this is something else entirely. Tens of thousands of times farther still. Imagine standing on a shore and realizing that the ocean before you is not 100 kilometers wide, not 1,000, but millions. The Oort cloud is like that, a boundary so distant that even light takes months to cross its outer edges. And yet, despite its scale, the Oort cloud is not dense. It is not a sea of comets, but a desert, vast, silent, and empty, with icy bodies scattered across unimaginable distances. You could travel billions of kilometers within the Oort cloud and never come near another object. Each icy fragment is separated from the next by stretches of space so wide that calling them neighbors feels almost comical. And, that emptiness is part of what makes the Oort cloud so haunting. It is both full and empty at once, full of objects, empty of proximity. But what fascinates me most is its origin. We often think of the solar system as a set of worlds that formed more or less in place, orbiting the sun in neat rows. But the Oort cloud tells a different story, a story of violence, scattering, gravitational chaos in the solar system's youth. When the giant planets were forming, their immense gravitational fields hurled billions of icy bodies outward, flinging them at such speeds that they escaped the inner solar system entirely. Some were ejected into interstellar space, lost forever. But many lingered in long, looping orbits, slowed just enough by the sun's gravity to remain bound. Over millions of years, these scattered fragments settled into a vast spherical cloud, the Oort cloud, a kind of fossilized record of the solar system's restless childhood. And because these objects orbit the sun at such staggering distances, their years are beyond comprehension. A single orbit for an Oort cloud object may take millions of Earth years. 1,000,000 years to complete one circle. Imagine a winter that lasts 100,000 years. Imagine a night so long your species would not live to see it end. Time stretches out here, dissolving into something the human mind cannot comfortably hold. And you know, the Oort cloud marks the true gravitational edge of the solar system, not the edge defined by sunlight, which fades slowly into interstellar night, but the edge defined by influence. Beyond the Oort cloud, the sun begins to lose its grip. Its gravity becomes so faint that passing stars or the tides of the Milky Way itself can tug objects away. The Oort cloud is like the outermost breath of the solar system, the point where the sun's dominion whispers into the dark. Beyond that lies the galaxy proper, a place where the solar system becomes just another star system among billions. Yet even here, at this imagined frontier, there is motion. Occasionally, a star will pass near enough to nudge an icy object, sending it spiraling inward. For most of its existence, that object is frozen, unseen, untouched. But then, gently at first and then, with increasing speed, it begins a journey toward the sun, a fall through gravity, a slow brightening, a long, cold descent that may take millions of years before it emerges near the inner planets as the bright tail of a comet streaking across our sky. And that moment, when a comet appears suddenly above us, is like watching an echo from the edge of the solar system. Something ancient, something born before humans existed, something that has traveled farther than any human-made craft ever will. Comets, in that sense, are messages. They are the only visitors from the Oort cloud that we can witness directly. They dip into the warm inner solar system, flare brilliantly as their ices vaporize, and then fade back into the darkness. Some return centuries later. Others leave and never return. Each is a fleeting reminder that the solar system is far larger than we see, far older, far quieter. The Oort cloud is the library of forgotten fragments, and comets are the pages that occasionally drift loose. And, the sheer distance of this region means that even if we launched a spacecraft today, in the year 2025, it would take thousands of years to reach the inner edge of the Oort cloud. To reach the outer edge might require tens of thousands of years. Human civilization would change beyond recognition before such a voyage could be completed. Entire cultures would rise and fall before a robotic explorer could glimpse the faint outer boundary where the sun's influence finally gives way to the pull of the galaxy. And that, perhaps, is the humbling truth. The Oort cloud is not simply distant. It is beyond the scale of human lifetimes. But even so, the Oort cloud gives shape to the solar system. It defines its outermost border. It is the true frontier, the final whisper of our sun's gravitational voice. And beyond it lies the Milky Way itself, a galaxy so large, so crowded with stars, so overwhelmingly vast that the entire solar system, even including the Oort cloud, becomes almost invisible. And that realization naturally carries us onward into the next layer of scale. If the Oort cloud is the boundary of the solar system, then what does the solar system look like within the galaxy? How does our star, small and average, sit within a spiraling disk of hundreds of billions of others? Well, that is where our journey leads next, into the deep sweep of the Milky Way, where the solar system becomes a single point of light among countless others, and where the vast distances we've traveled so far become small compared to the architecture of the galaxy itself. Well, you see, As we drift beyond the imagined edge of the Oort cloud and let that vast, ancient sphere of icy fragments dissolve into the dark behind us, something profound begins to settle over the mind. For the first time in our long journey outward, we are no longer describing the solar system itself. We are describing where it sits, and perhaps that shift feels gentle at first, like the moment you walk out of your house and suddenly become aware of the city around you. But here, in this cosmic context, the scale widens so dramatically that even the distance we've traveled so far, billions upon billions of kilometers, begins to feel strangely small. And I suppose the first humbling truth is this. When viewed from the Milky Way, the entire solar system, from the blazing surface of the sun to the farthest edges of the Oort cloud, becomes nothing more than a tiny spark floating in a vast, spiraling sea of light. The distances we've spoken of, stretching across planetary orbits and icy belts, are swallowed instantly by the enormity of the galaxy. It's like comparing the size of your home to the size of the Earth, except the galaxy. Well, it makes even Earth's scale feel manageable. You know, the solar system occupies a region of space so minuscule compared to the Milky Way that if the galaxy were a great city stretching 100,000 kilometers across, the solar system would be a single house tucked quietly on one corner street. And not even a large house. More like a grain of dust floating above the pavement. We tend to imagine our star as the center of something, the bright anchor of a grand structure. But in reality, the sun is an ordinary star, one of hundreds of billions scattered throughout the Milky Way. It shines with warmth and familiarity to us because we live so close to it. But out there, among the galactic spirals, it is indistinguishable from countless other points of light. And the Milky Way itself. Well, the numbers begin to strain against comprehension. 100,000 light-years wide. A thickness of thousands of light-years, each light-year containing distances so vast that even our fastest probes would require tens of thousands of years to cross them. And all of this filled with stars, some huge, some small, some ancient, some newborn, scattered across its luminous arms in clusters, in clouds, in great swirls of cosmic dust and gas. When you take a step back and imagine it, the entire solar system becomes something like a single spark drifting through an ocean of fireflies. And perhaps the most humbling part is that our sun is not special, not unusual in size, not remarkable in brightness, not positioned in any privileged location. It drifts about halfway between the galactic center and the outer rim, circling the galaxy once every 200 million years or so, as though it were taking a leisurely stroll along one of the Milky Way's sprawling spiral arms. And during that orbit, the solar system passes through regions of varying density, through clouds of interstellar dust, through gravitational tides shaped by clusters of distant stars. We are not fixed. We are moving slowly and endlessly, carried along by the galaxy's immense rotation. Imagine that for a moment. Every creature that has ever lived, every thought ever formed, every structure ever built, every moment in human history, all of it occurred while the sun has been drifting through the galaxy. And during the entire history of our species, we have barely moved a fraction of a degree along the Milky Way's great circle. If Earth's entire civilization were a single second on this cosmic clock, the sun's orbit around the galaxy would be millions of years long. And that sense of duration, of movement stretched across time so vast it dissolves into abstraction, gives the galaxy a kind of slow majesty. We imagine galaxies as swirling structures frozen in telescopic images, but they are living forms, changing, rotating, evolving over hundreds of millions of years. Stars are born in their arms, live their quiet lives, and die in brilliant eruptions that seed the next generation of stars. The galaxy breathes across epochs. And still, in this immense structure, our solar system is nearly invisible. If we could hover above the galaxy and look down upon it, with the impossible clarity of some cosmic observer, the sun would not appear as a glowing sphere but as the faintest pinprick, lost among more luminous stars, and even then, you would struggle to isolate it. You would look down at a river of starlight and see nothing that marks our place. The Oort cloud would vanish into invisibility. The planets would be too close to separate. Earth, with all its oceans and clouds and fragile life, would be beyond microscopic. And perhaps this is where the emotional side of things begins to settle in, because the idea that everything we know, everything we love, everything we remember, is happening inside a tiny, nearly invisible corner of one average galaxy, well, it stirs something inside us. It creates both humility and wonder. Humility, because we are small. Wonder, because even in that smallness, we find meaning. But the galaxy is not merely a place of poetic vastness. It is also a place of relentless scale. Hundreds of billions of stars, billions of planets, nebulae stretching dozens of light years, black holes lurking in the center, star clusters drifting like cosmic flocks, and the space between stars is so wide that even light takes years to cross from one to another. The nearest star to the Sun, Proxima Centauri, is more than 4 light years away. 4 years for light to travel the distance, and for humans that journey would require tens of thousands of years with current technology. And that is the closest star. Most are far more distant. And yet, despite the coldness and enormity of space, the galaxy has nurtured stars, planets, and life itself. It is, in a strange way, a cradle, vast and indifferent, yes, but also profoundly generative. And when we imagine the solar system drifting quietly along one of the Milky Way's spiral arms, it feels as though we are riding on a small boat carried by an ocean current, a current so wide we cannot see its edges, so deep we cannot imagine its bottom. And, perhaps this is the most striking truth. The galaxy doesn't even notice us. It doesn't bend or change because of our presence. And yet we study it, we map it, we look at it with awe. Our tiny perspective, our brief human insistence on meaning, becomes its own kind of light. But now, as we hold this grand image of the Milky Way in our minds, a natural question arises. If the solar system is nothing more than a dust mote drifting in a luminous storm of stars, if the galaxy itself dwarfs everything we've traveled through so far, then what does that say about us, about humanity, about the meaning we carve into our tiny world? Well, that reflection carries us gently toward the next chapter, where we no longer talk about planets or stars or clouds of icy debris, but about ourselves, our size, our fragility, and the strange, beautiful way we find belonging in a universe far larger than anything our ancestors ever dreamed. Well, you see, as we pull our gaze away from the Milky Way's great spiral and let that vast, star-filled river drift into the background, something intimate begins to rise within the silence. After all this wandering, past planets, past belts of ice, past the ghostly sphere of the Oort cloud, we finally arrive at a question that feels far closer than any comet or distant star. A question not about worlds or structures or gravitational borders, but about ourselves. Because, once you understand the scale of the solar system, and then the galaxy, there is an inevitability to the next realization. Everything we know, everything we are, is impossibly small. And I suppose it begins with this simple, humbling truth. Every moment of human history has unfolded on a fragment of rock smaller than a cosmic grain of dust. If you could shrink the Milky Way to a single city, our entire solar system would disappear from sight. And if you could shrink the solar system to a house, Earth would be a speck of dust floating in a sunbeam. Every book ever written, every whisper, every discovery, every love, every memory, compressed into that one fragile speck. Well, you start to understand why astronomers sometimes fall silent mid-sentence. The scale is not merely large. It erases every familiar notion of size altogether. And perhaps that is where our minds, evolved for walking across fields and predicting the path of thrown stones, struggle most. We were never built to comprehend distances measured in trillions of kilometers, or timescales measured in billions of years. Our ancestors needed to read the weather, not the stars. They needed to understand the next hill, not the next galaxy. And yet, here we are, in the year 2025, trying to stretch a brain shaped by survival into a universe shaped by eternity. It is no wonder that space feels overwhelming. No wonder diagrams mislead us. No wonder intuition fails. You know, sometimes I imagine the human mind as a lantern glowing softly in a cavern so vast that the walls never return its light. We illuminate only the nearest stones, the nearest memories, the nearest needs. Everything else dissolves into black. And in a way, that is what makes our pursuit of understanding so tender. Despite our limitations, we still reach outward. We still measure the stars. We still build telescopes to challenge our senses. We still ask questions that stretch our inner landscape. But, the universe does not comfort us with scale. Consider this. The distances between planets are so immense that they dwarf the planets themselves. The distances between stars are so unfathomably large that even the distances between planets become tiny by comparison. And the distances between galaxies, well, at that point, even poetic metaphors begin to fail. And yet humans, small, temporary, fragile, insist on understanding. We insist on charting the invisible, naming the impossible, and folding meaning into places where physics alone would be enough. Perhaps that is what makes us unique. Not our size, not our strength, not our significance in cosmic terms, but our yearning. We live on a dot suspended in a void nearly empty of matter, a void where 99.999% of everything is nothing at all. A void where light itself, light, the fastest thing we know, still takes years to cross the nearest gap between stars. Space is not a sea of stars. Space is a sea of emptiness punctuated by islands of fire. And yet, in that emptiness, life appeared. Not because the universe meant for it to, but because conditions aligned just long enough for chemistry to wonder about itself. You and I are part of that wondering. Our minds are carved from stardust, yes, but also from curiosity. And that curiosity, well, it is the thread that pulls us through the darkness. When we study the solar system's scale and feel overwhelmed, it is not a failure of comprehension. It is a reminder that the universe is bigger than the stories we tell, bigger than the boundaries of our intuition. And you see, there is something beautiful about acknowledging our smallness. When we admit that everything we know sits on a dot in an unfathomably vast galaxy, the world does not lose meaning, it gains it. Because suddenly every breath becomes precious, every sunrise becomes rare, every act of kindness becomes statistically astonishing. To exist at all in a universe that favors emptiness over form, silence over sound, darkness over light, is already extraordinary. And perhaps that is why cosmology often feels like philosophy in disguise. When you press your mind against the scale of the universe, it presses back. It asks questions you didn't intend to ask. Questions like, what does it mean to matter? How do we find belonging in a cosmos that does not know we exist? Why does understanding the vastness make us feel not lost, but connected? And maybe the answer lies in perspective. Yes, the universe is enormous and we are small, but small things can still be luminous. A photon is small, but shapes entire galaxies. A neuron is small, but shapes entire lifetimes. A human thought is small but capable of spanning light years in imagination. Even now as we speak, your mind is drifting across billions of kilometers, stitching together an understanding of scale that no other species on Earth has ever held. Our smallness is not a weakness. It is the canvas upon which wonder emerges, and, once you reach this point in the journey, past planets, past comets, past clouds of ice, past the very edge of the sun's gravitational whisper, you begin to realize something else as well. The true story of the solar system isn't the planets. It isn't even the sun. It's the void between things. The emptiness is the main character. The vastness, the setting in which every world is merely a brief punctuation mark. And we, somehow, are the ones who notice. Everything we've explored so far reminds us that intuition is too small for the cosmos. Our minds evolved to survive, not to comprehend light years. But despite that, we keep trying. We expand our imagination a little farther each generation. We build new ways of seeing. We ask new questions. And in doing so, the universe becomes just a little less distant, a little less cold. We become, in a sense, participants in the cosmos, rather than mere spectators. And perhaps that is where our journey naturally turns next. We have looked outward, farther and farther, until distance itself became abstract. But now, having pressed against the unfathomable edges of the Milky Way, a new question begins to rise within the quiet. If the universe is so vast, so empty, so overwhelmingly beyond our scale, what does it mean that we are here thinking about it? Well, that is the doorway we step through next, the final reflection, where we let the entire journey fold back into a single, human-sized moment and consider what it means to live briefly in a universe so wide it nearly defies understanding. Well, you see, once we arrive at that quiet doorway between the vastness of the galaxy and the smallness of a single human thought, something gentle begins to stir, a kind of inward turning after so much outward exploration. We've drifted past planets and dust and ice, past stars and spirals, past the enormous architecture of the Milky Way itself. And now, as we hover in that soft conceptual space between the cosmos and the mind that contemplates it, a deeper question emerges, almost shyly, as though aware of its own fragility. If the universe is so vast, so ancient, so overwhelmingly indifferent, then what does it mean that we are here at all, thinking about it? And, that question, well, it has a way of echoing quietly through the chambers of thought, because the story of space, a story of distance, emptiness, and cold, seems at first incompatible with the story of us, a story made of warmth, consciousness, memory, and meaning. But perhaps the contrast is the point. Perhaps it is the vastness that makes our brief presence so extraordinary. You see, everything we've spoken about, the planets, the belts, the clouds, the galaxy, existed for billions of years without a single mind to notice them. They spun and drifted and collided and formed under laws that cared nothing for awareness. And yet now, here we are, in the year 2025, small beings on a small world, describing the edges of existence as though our lantern of understanding could illuminate the whole cavern of the cosmos. And I suppose that's what makes this chapter feel so human. When you realize that everything you know, your entire life, your memories, your hopes, fits within a momentary flicker of cosmic time, you might expect that feeling to overwhelm, to diminish, to erase meaning. But curiously, it often does the opposite. It brings a kind of tenderness, a sense of preciousness. Life begins to resemble a candle in a dark cathedral. The more immense the darkness, the more miraculous the flame. You know, we often imagine ourselves as separate from the universe, observers looking outward. But in truth, we are part of the same unfolding story. The atoms in our bodies were forged in stars that died long before the sun was even born. The carbon in our cells, the iron in our blood, the calcium in our bones, these elements were crafted in furnaces of unimaginable heat, then scattered across space by ancient explosions. In a very literal sense, we are made of the galaxy. We are not visitors here. We are expressions of it. And yet, despite this cosmic lineage, our minds remain small and pragmatic. They evolved to recognize faces, not galaxies. To remember paths through forests, not the paths of stars through spiral arms. And so when we try to hold the universe in our thoughts, the mind falters, slips, hesitates. It is like trying to cup an ocean in your hands. And perhaps that is why the true scale of the solar system, or the Milky Way, or anything beyond our immediate experience, feels so unreal. We were not built for this, but we reach for it anyway. And that reaching is, in its own quiet way, beautiful. What fascinates me most is the paradox at the heart of this. We are tiny, yes, smaller than dust when measured against the galaxy, and yet the galaxy cannot contemplate itself, cannot ask questions, cannot tell stories. Only beings like us can do that. And so the universe becomes aware of itself in some meandering, imperfect way, through minds that evolved on a world too small to appear even as a pixel in a typical image of the Milky Way. Our insignificance and our significance sit side by side, neither canceling the other. And maybe that is why, when we talk about the enormity of space, there is always an emotional undertone, a quiet uncertainty, a wondering, a lingering question about belonging. For all its vastness, the universe offers no map of meaning. It offers patterns, yes, laws of physics, yes, but meaning, purpose, those are things we create. And perhaps by creating them, we leave a trace of ourselves that stretches farther than our brief lifespans. But I suppose the most striking realization, after journeying through distances so immense that even light travels for years or centuries or millennia, is this: everything we know, our entire history, fits within a sliver of cosmic time. Civilizations rise and fall in the blink of a stellar eye. Species emerge and vanish before the galaxy even notices. And yet, somehow, in that briefness, life learns to wonder. That, I think, is our quiet rebellion against the scale of the cosmos. We refuse to be silent dust. We become dust that questions, dust that dreams, dust that imagines what lies beyond. And, perhaps that's where humility enters the story. Not the humility of feeling small in a frightened way, but the humility of understanding our place with clarity. We know now that the emptiness between worlds is not a failure of imagination. It is a statement about the nature of the universe. Most of everything is nothing. Matter is a rare interruption. Life is rarer still. Consciousness rarer yet. And the fact that consciousness ever emerged at all, even once, on even one world, should make us pause. Because in a universe where silence is the default, awareness is a kind of cosmic anomaly. You see, when we picture ourselves from the outside, from the perspective of the galaxy, we appear almost laughably tiny. Our entire species could vanish, and the Milky Way would not flicker. Stars would continue to form and die. Planets would continue to orbit. Nebulae would continue to glow. And yet, when you look from the inside, from the perspective of a single human moment, the world is enormous, intricate, intimate, meaningful. And that duality is perhaps the most human thing of all. And it leads us to another truth. Our ability to feel wonder is not diminished by our smallness. It is enhanced by it. Wonder emerges when something is larger than our understanding, but still close enough to touch with imagination. The solar system is like that. The galaxy is like that. The universe is like that. They remain distant, indifferent, enormous. But we lean toward them anyway, lanterns in hand. And yes, in the year 2025, our knowledge still has edges. We do not know how life began. We do not know whether it exists elsewhere. We do not know what lies like a faint whisper beyond the observable universe. But uncertainty is not a void. It is an invitation, a horizon, a place where curiosity collects itself and takes another step. And perhaps that is the essence of being human in the cosmos. Not to dominate, not to understand everything, but to wonder honestly. To live briefly yet ask questions that stretch across light years. To be small yet strive toward the infinite. To feel, even for a moment, the fragile beauty of awareness in a universe vast enough to ignore it. But now, after tracing this thread of human, meaning through the scale of the cosmos, another question begins to rise gently from the quiet. If we are small, and the universe is wide, how do we return from this journey with a sense not of despair, but of connection? Well, that realization leads us toward the final reflection, where the entire cosmos contracts back into the human heart, and we explore how something so vast can still feel like home. Well, you see, after wandering through the vast corridors of the solar system, after drifting beyond the planets and the comets and even the soft, imagined frontier of the Oort cloud, and after lifting our gaze to the immense sweep of the Milky Way, something begins to quiet inside us. It's as though the journey outward has stretched a thread across our thoughts, pulling gently, almost imperceptibly, on the part of us that wonders what any of it means. And perhaps, now that we've arrived at the final turn, the question is no longer about distances or temperatures or gravitational borders at all. It is about something softer, something more human. How do we hold all this vastness, this cathedral of emptiness and light, inside a mind evolved for the scale of forests and rivers? And, I suppose the first answer is that we don't hold it neatly. The universe is too large for that. The mind tries, yes, but it slips. It forgets. It shrinks the planets in diagrams and pulls the stars closer in imagination. It compresses the spaces because the true distances swallow language. And yet, even though our intuition fails, our curiosity does not. It stretches, like a hand reaching through darkness towards something it knows it will never fully grasp. And somehow, that reaching becomes its own kind of meaning. You know, in the year 2025, when we look at the illustrations of the solar system online or in school books, most of them lie to us, gently, helpfully, but undeniably. They squeeze the planets together so they can fit on a single page. They shrink the empty spaces, broaden the worlds, brighten the sun, narrow the void. And perhaps they must do this, because if they showed the true scale, you would see almost nothing at all. Just a blazing dot and long, long corridors of black. The truth is that the remarkable thing is not the planets. It is the emptiness between them. The solar system is mostly nothing. The galaxy is mostly nothing. The universe, overwhelmingly, is an ocean of almost nothing. And here we are, small and temporary, making meaning inside a vastness that does not speak. But perhaps that is exactly why the universe feels so astonishing. Because even though it is empty, even though it is silent, we fill it with stories. We fill it with metaphors and questions and quiet longing. When we stare up at the night sky, we do not simply see cold stars. We see possibility. We see memory. We see a reflection of our own desire to understand. And that desire, well, it is one of the rarest things the universe has ever produced. Imagine again the distances we've traveled. The sun, so huge it dwarfs 1,000,000 Earths, but so far from Neptune that its warmth becomes a whisper. Mars, close in imagination but months away by spacecraft. Saturn, glowing softly behind its rings, separated from us by billions of kilometers of deep cold. And beyond all of them, the Kuiper Belt, stretching outward like a frozen echo. And beyond that, the Oort cloud, not a place but a concept, half a light year of faint, unseen fragments drifting in a gravitational sleep. And then the galaxy, immense beyond comprehension, turning slowly, carrying us with it. 100,000 light years across, hundreds of billions of stars, every star with its own story, its own family of worlds, and at the scale of that story, everything we have ever done exists on a speck too small to draw without losing it. But I suppose what makes this ending feel tender rather than crushing is that, despite everything, we still matter. To ourselves, to one another, to the fragile thread of life running through Earth's thin crust. We don't matter to the galaxy, no. The galaxy does not notice our existence. But meaning was never something the universe owed us. It is something we create, something we carry, something we extend into the dark the way early sailors extended lanterns across unknown seas. And perhaps that's the quiet beauty of being human. We live in a universe that does not offer instructions, yet we build constellations in the sky to guide us. We live in a cosmos where distances swallow centuries, yet we send spacecraft across billions of kilometers just to glimpse a world no one will ever walk upon. We live in a galaxy where stars are born and die without witness, yet we name them, study them, fold them into myths. We live on a speck, but within that speck, we create music, language, love, memory. We carve universes inside ourselves that are every bit as mysterious as the cosmic one beyond us. And, maybe that's why the ending of this journey doesn't feel like a closing at all. It feels like a beginning. Because once you've seen the scale of the solar system, not the simplified diagrams, not the tidy classroom models, but the true distances, the true emptiness, you begin to understand that reality is far larger, far quieter, far more wondrous than intuition ever allowed. And that understanding, that stretching of perception, changes the way you look at everything. A sunrise becomes not just sunlight, but a gift from a star whose energy took more than 100,000 years to escape its core. A moonlit night becomes not just beautiful, but a reminder of a world 400,000 kilometers away, circling us with patient calm. Every breath becomes a whisper of atoms forged in stars long gone. Every thought becomes an echo of the universe discovering itself. And perhaps, after wandering through the cosmos in our minds, we return to Earth with a newfound sense of gentleness. Because this world, this little blue speck orbiting a star that doesn't know we exist, is rare, fragile, precious. It is easy to forget that when we are caught in the noise of daily life. But from the vantage point of the cosmos, Earth becomes a miracle carved out of darkness. And now, standing here at the threshold of the ending, the story does not collapse inward. It expands. Because the next question, the one that rises softly, naturally, inevitably, is not about distance anymore. It is about connection. If the universe is vast and we are small, then how do we carry this understanding forward? How do we live with awe as a companion, not as a stranger? How do we let the cosmos shape our humility without dimming our hope? Well, that is the invitation that waits ahead, the next gentle turn in the path. A turn where the universe does not feel like something far away, but something we are part of. Something woven into our bones, our stories, our breath. And from here, I suppose the journey continues not outward, but inward, into the space where wonder meets meaning.